Okay, today we're going to talk about, we're going to go over the solutions for the H3 vectors study guide. Okay, so the first thing we're going to do, I'll rewrite this since it looks kind of messy. So we've got 3 points in the garden, A, 2, 0, 0. So what we've got here, we've got, if I want to write this point as a vector, A, 2, 0, 2. And basically this is saying how far the vector that gets you from the origin is 0, 0, 0. The vector that gets you from the origin to this point, 2, 0, 2, is the vector that gets you to that point. B is equal to 8, 0, 2, and C is equal to 5, 4, 3. Okay, so we've got these position vectors. Okay, so if I want to find vector CA, the first thing I'm going to do is I'm going to write vector A, the second one here, which is the 2, 0, 2, minus, 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 and then I have the C values, which is 5, 4, and 3. And this gets me the vector that takes me from point C to point A. Now, to find out vector CB, I start off with vector B, so the 8, 0, 2, and then minus, 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 and then I put the values for C, which is the 5, 4, and 3, and then subtract those, and I get this. Okay, now find the cross product of CA times CB. So this is super important. Okay, so I'm sure there's going to be something like this on the IB test. Okay, so I've carefully written the these solutions here: the -3, -4, -1, 3, -4, -1. Okay, so for this first row, I have the -4 times the -1 minus -1 times -4. Okay. For the middle line, I'm going to use the top row here and the bottom row here. So I do -1, this one down here, times the 3, minus this one up here, the -3 times the -1. Make sure you're careful with this middle line. The middle line, we start off with a -1 times the 3, minus the -3 times the -1. And then the bottom row, I'm going to use this top row and the middle row to get this value. So I start off with the top here, -3 times -4, minus -4 times 3. Okay, and when you're taking the IB test and you're not sure which ones to use, you can look at your formula packet, and it's right here when it says vector product. Okay, and this is what you're going to be using here. So you don't need to memorize the order of the things. It's right here in the formula packet. Okay, so then I get my cross product. So when you get cross product, you end up with a vector. So the last question says, hence find the area of the triangle. Okay, so to find the area of any triangle, the formula is to find the area of a triangle is going to be the magnitude of the cross product. Okay, so first I've got the cross product here. So now I'm going to find the magnitude of these two. So I'm going to have 0 squared plus -6 squared plus 24 squared. So then I end up with 36 plus 576 gives me this and this value. Now I've got my magnitude here, and I divide it by 2 in order to get the area of a triangle. Okay, and there we go. Okay, if you look at the formula packet, it says the area of a parallelogram. So guess what? A triangle, you have to just divide it by 2. Okay. Next one. Okay, the submarine is located at this coordinate relative to the ship at origin 0. The x direction due east, the y direction is due north, and z direction is vertically upwards. Okay, all the distances are in kilometers. The submarine travels at a direction vector of this. Okay, so assuming the submarine travels in a straight line, write down the equation of the line as follows. So the equation of the line is going to be, we've got r, and is equal to our position vector, which is these values here, plus t times our direction vector there. So here is our equation of the line. Okay, next part. The submarine reaches the surface of the sea at point P. Find the coordinates of P. So when the submarine reaches the surface, that means the z component is going to be 0, because in a three-dimensional space, z is the height vertically, up and down, up and down. Z is the height up and down. So when it reaches the surface, it's going to be at 0. So if you look at our original location where we're starting at, we're at negative 0.3. So that means we are underwater at this point. Okay, I don't think the submarine is going to float above the water in this example. So we want to find out, when is this going to be equal to 0? So I use the bottom row, negative 0.3 plus t times 1. So I have negative 0.3 plus t times 1. So I can add 0.3 on both sides, and I get t is 0.3. Okay. Question number 2. Find the magnitude of O to P. So we're trying to figure out the distance between the origin and this new point P. So we're starting off. Okay, so first of all, before we even get started, I need to find out where point P is at time 0.3. So I'm taking my original position. We know the time here is 0.3, and I'm multiplying the 0.3 times my direction vector. So 0.3 times negative 2 gives me this, 0.3 times negative 3 gives me this, and 0.3 times 1 gives me this. Okay, and so now I'm going to take my position vector and adding it with these values here, and now I get this is where point P is. Okay, this is the coordinates of point P. Okay, so now to find the magnitude. So the magnitude is the distance from the origin to point P. So I've got point P. So to find the magnitude, I take the square root of, and then 0.2 squared plus 0.4 squared plus 0 squared. Okay. Next question. Okay, a vertical pole stands on a sloped platform. Okay, the bottom of the pole is at the origin. Okay, of the coordinate system. The top is point F, and the pole coordinate here is 0, 0, 5.8. All units are in meters. Okay, the pole is held in place by a bunch of ropes attached to the top here. Okay, one of these ropes is attached at point A, at this coordinate here. The rope forms a straight line from A to F. Okay, so the first question is, find the vector from A to F. Okay, so I take the values of, so from A to F, I take the values of F, and minus, 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 and the values of A. Okay, so this is the vector AF. Question B says find the length of the rope. To find the length of the rope, I need to take the magnitude, and there we go. And then to find angle AO, FAO, so we're going to be using our angle between two vectors here. So this is cosine theta equals V dot W divided by the magnitude of V and the magnitude of W. Okay, so I'm going to find three things. The dot product between the two vectors, the magnitude of v, magnitude of w. So, um, so the two vectors I'm going to use are the AF and the AO. Okay, so negative 3.2 times negative 3.2 plus negative 4.5 times negative 4.5 plus 0.3 times 6.1. Okay, divided by the magnitude of AO. So the magnitude of AO is negative 3.2 squared plus 0.5 squared plus 0.3 squared, which gets me. And then this one here, we already found out the magnitude of AF. It's this value here. Okay, so I take this value here, divided by this, and I get this answer. And then I do the inverse cos. So second cos this value, and then I get my answer. In degrees or radians are both acceptable. Okay. Question 4. Okay. At 1 p.m., a ship is 1 kilometer east and 4 kilometers north of the harbor. Okay. The position vector of that is 1, 4. Okay. The ship has a constant velocity of 1.2 and negative 0.6. Okay. Write down an expression for the position vector of the ship after 1 p.m. Okay, so the position vector equation is going to be, so the vector equation r is going to be equal to my initial position plus the velocity times time. So my initial position is 1, 4, and my velocity here is 1.2 over negative 0.6. Okay. Find the time at which the bearing of the ship of the harbor is at 45 degrees. Okay, so so at 45 degrees from here, so north, this is north, right? And that's at 0 degrees. So at 45 degrees means I'm going over this far, and I'm going this way. So at 45 degrees, this distance here, A, and this distance here, A, are equal. So at 45 degrees, the x and the y components are going to be equal. So I'm just, since I don't know what this value, this coordinate is right here, I'm just going to say this x value is A, this y value is A. So here is my equation that we just wrote from up above. And instead of writing x and y, I'm just going to write A and A. Okay, and so we've got our initial position, we've got our velocity, we've got our time. Okay, so I'm going to make, so since this A equals this and A equals this, I can make the top row equal to the bottom row. So I've got 1 plus 1.2, which is right here, equaling to 4 minus 0.6t. Okay, and then I can solve, and then I figure out that t is equal to 5/3, or 1.66, or an hour and 40 minutes. So find the time at which the bearing of the ship is 45 degrees. So we started off at 1 p.m., so, and an hour and 40 minutes later gets me here at this time. Okay. Okay, people had difficulty with this one, so we should spend a little bit of time with this. So we've got this line vector here, and they gave you this, and this line vector here. And so I rewrote this in this form here. So as a form, so what I did was I took my values that don't have the letter P, and those are the values that help me find a position vector. The letter P can represent time in this example. This is the value that changes for the equation of the line. So these values that are multiplied by P are going to help me figure out the direction vector, because p changes over time. So anything with a p, it tells me where on the line I am going in that direction. So same thing with this other one, the -2, the 1 helps me with the direction vector, and q, -q, and 2 is going to help me get the direction vector. Okay, let's get started. Okay, find the coordinates of M. M is where the two lines intersect. So basically, the first thing I'm going to do is I can get this top. If they're going to intersect, that means this x value and the y value are going to be equal. This x value and this x value are going to be equal. This y value and this y value are going to be equal. This z value and this z value are going to be equal. So I'm going to make 3 plus 4m equal to q minus 2. Okay, I add 2 on both sides, and this gets me in a value for q. 3p plus 6 gives me a value for q. Then I could use substitution. And then I solved for p. So I'm replacing q with 3p plus 6. Okay, I replaced q with that, and then I solved for p, and I got p equals -5/4, or the answer key, the mark scheme says it's -0.8. That's fine. Okay, so now that I know the value of p, I can plug in 0.8 into my original equation. So 3, instead of p, I'm writing -0.8 plus 6 equals q, and now I can solve for q. Okay, and so we still haven't found the coordinates for m, but I needed to figure out the value of p and q. Actually, I could have just found out one of either p or q. I didn't really need both of them, I guess. So to find the value of m, so we know that p is this value here, right? So using this equation, 3p plus 4, I'm just going to write 3 times -0.8 plus 4. And then 2p minus 1, I'm going to write 2 times -0.8 minus 1. And the last line, p plus 9, I'm going to have -0.8 plus 9. Okay, and then this gets me the coordinates of m. Okay. B says find the acute angle between the two lines. So once again, we're going to use this equation from our formula packet. So to find the angle, I have to do the dot product of the two vectors divided by the magnitude of the two vectors. So I'm going to be using the direction vectors, which are these blue ones here. Okay, so the dot product of these vectors, 3 times 1 plus 2 times -1 plus 1 times 2. Okay, so that's my dot product. Okay, so now I need to find the magnitude of each of these. I get this, magnitude of that, I get this, and now I plug it into here. 3 divided by square root of 14, and square root of 6 gets me this decimal. And then I hit second cosine, and then I'm going to get my angles. Either answer is fine. Okay, next one. Okay, so we've got a ship traveling with this velocity. At time 0, the ship is at this position where distance is measured in kilometers. Find the position vector OS of the ship at time t hours. So basically they want me to find an equation, r equals r0 plus t times the velocity. Okay, so we know the velocity is -12. Oops, can't see what I'm doing. So here's my velocity. And my initial position, they've told me, is 300 over 100. Okay. So that's the answer. So I've got my equation. This gives me the position of OS at time t. Question B. The lighthouse is located at this point. Find the value of t when the ship is closest to the lighthouse. Okay, so I'm going to be using my calculator, and I'll show that on my calculator in just a second. So the distance, find the value of t when the ship is closest to the lighthouse. So we need to figure out the distance between this point of wherever the boat is minus the coordinates of the lighthouse, 29, 283. So, so here, this right here is OS. I guess OS. All right, 300 minus 12t, and then 100 plus 15t, and then OS. I don't have another color, but this is going to give me OS. Okay, so then I get 300 minus 12t minus 129. Combine the like terms, and I get this and this. Okay, so now I need to figure out the magnitude of this. So I'm going to say the top thing, 171 minus 12t parentheses squared plus negative 183 plus 15 x squared. So I need to type this into my calculator. Okay, so let's do that. So, okay, so parentheses, 171 minus 12x, close parentheses squared, okay, plus, open parentheses, negative 183 plus 15x, close parentheses squared, enter. So this is the equation of the magnitude, the distance between the wherever the ship is, which is OS, and the lighthouse. So this is going to tell me the distance between the ship and the lighthouse, and we're trying to find the closest the ship will get to the lighthouse. So then if I graph this second, okay, if I hit graph, and then all of a sudden you see nothing. Oh no! So we need to change the window here. So I'm going to change the X max to 20. Let's see what happens. And oh no! So let's change the Y max to something bigger. Hit window. I'm going to change the Y max to 40. Let's see what happens. Okay, so here we go. We can see our graph now. So the shortest distance is I'm going to have to find the minimum of this point. So to figure out that minimum of that point, I'm going to have to hit second trace. You may want to copy these steps down if you don't remember. We're finding the minimum, 3, enter. And I need to do left bound. Okay, 5, so I have to I'm hitting this right arrow to get me onto this graph here. Oh, okay, there it is. So I'm on the left of the minimum. So I hit enter. Now it says right bound. I need to go to the right of where my pen is pointing. I'm hitting the right arrow to get me, okay, I'm to the right. I hit enter. It says guess. I hit enter, and now boop, 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 boop. Okay, so this coordinate here is 13, 19.2. Okay, so here's my coordinate 13, 19.2. So this basically has told us that the ship is closest to the lighthouse at 13 hours. 13 hours. Okay, so, and we just said at 13 hours, the boat is 19.2 kilometers from the lighthouse. So they said the alarm is going to sound when it's less than 20 kilometers for the lighthouse. So therefore, the alarm is going to sound just like that. Okay, so 2 lines, line L1, L2, are given with the following equations. It is known that they are perpendicular. Okay, so things that are perpendicular, if they're perpendicular, then that means the dot product of the vector is going to be 0. So I'm going to have, and so it's the dot product of the direction vectors. I think people weren't sure which vectors to take the dot product of. So p, 2p, and 4, and p plus 4, 4, and negative 7. So I take the top values, p times p plus 4, plus 2p times 4, plus 4 times negative 7, and we make that equal to 0. So p times p, so it gives me p squared. P times 4 gives me 4p. And it simplifies this way. So I end up with p squared plus 12p minus 28. And then I factor this. What two things multiply to give me 28? And subtract to give me 12. And it's going to be 14 and 2. So that means p has a value of negative 14. And p has a value of 2. Okay. In the case that p is less than negative 0. So we're going to be using negative 14. Okay. We got these two values, but in the example, when p is less than 0, determine whether the lines intersect. Okay, so if the lines intersect, that means these equations will be equal. Okay, so basically, I'm going to take this equation here and this equation here, and so I could take any two lines. So I took 2 minus 14 lambda equals 14 minus 10u. And I also took negative 5 minus 28 lambda equals 7 plus 4u. And negative 3 plus 4 lambda equals negative 2 minus 7u. So you can use elimination or substitution, and you're going to find out that they do not intersect because you're going to get two different values for lambda and for mu. Okay, I'm going to show you in a month or so how to find these solutions using matrices. So, and I hope that review works well.